Question number 46 from class 12, let's see Verma. We have an infinite ladder, and that ladder, something like this, is constructed with 1 ohm and 2 ohm resistors, and it keeps going on for infinity. What we need to find out is the effective resistance between point A and point B looking through this side of the circuit. And then find the current that passes through the 2 ohm resistor nearest to the battery, nearest to this battery. Okay, so that, and this is the 2 ohm resistor. Sorry, this is 1 ohm resistor, this is the 2 ohm resistor. So how does this circuit works first? So let's say because of this 6 volt battery and because of this resistor, some current starts flowing this, and at this point the current gets divided in this and this. And so the current that comes here will be less than that the current was flowing here, because a part of the current comes through this and comes back to the battery. A part of the current that comes here further comes at this junction, and then a part of it is further returns here, and even a smaller part comes into this resistor, and then the current keeps getting smaller till the infinity. And at some point in the infinity, the current becomes negligible and then zero. So how do we solve this problem? How do we find the current in this circuit or the effective resistance? So the trick in all this infinite ladder resistance problem is to see that, let us assume that between A and B, looking at this point, the resistance is R. The trick is that if you mentally remove this ladder, and instead of looking from A and B, let us say you are looking at one step ahead. I close this and you are looking at the circuit from here towards this, from these 2 points. Then this circuit that we are seeing from here all the way to infinity is the same as the circuit that we see between these point 4 across this, because of the infinity structure. So what it means is that we can replace this whole circuit going to the infinity, assuming that the resistance looking between A and B is R. We can replace the circuit between this to infinity by a resistor R. And when we do that, our circuit simplifies to this. And this is the thing that we will need to do on all infinite ladder circuit problems. 2 and R are in parallel, so their effective resistance is 2 into R divided by 2 plus R. And then this resistor 2R and R plus 2 and 1 ohm are in series, so we have 1 plus 2R divided by R plus 2 is the equivalent resistance of these two resistance, and that is the resistance R when we look from here. So this whole term becomes equal to R. We can simplify this, multiply R with R plus 2 here, and this is R plus 2 plus 2R over here. R square, 2R, and 2R gets cancelled. Minus R minus 2. R is equal to minus B plus minus square root of B square or 1 square minus 4 into minus 2, which is 8. 1 plus 8 is 9, square root 3, 1 plus minus 3 divided by 2. We disregard minus sign, we get 1 plus 3 divided by 2, or R is 4. What does that mean? That means the circuit looks like 6 volt power supply supplying current to 1, 2 and 2 ohm resistor like this. Now 2 ohm and 2 ohm are in parallel, so we have equivalent circuit as 6 volt supplying current to 1 and 1 ohm, which seems to be in series. So the current through this circuit will be 6 volt divided by 2 or 3 ampere. The whole equivalent resistance of this circuit looking from A to B is also 2, or we have found this value from R equal to 2 ohm. The final question is, if this is 3 ampere now, what is the current in this resistor? So we know that these two resistors are equal, so it gets equally divided between these two, and the current will be 1.5 ampere in each of these two resistors.